3. Jump down to number 5. Thoughts on what we could do with number 5? I'm probably going to need to make the denominators match. So I'm going to need to... Well, I guess there's a couple things I could do.
You can't cross them out yet.
Yeah, definitely can't cross them out and get 1 plus 1 equals 2 or something. I can't cross them out. If I want to add
You have to make the
denominators, they have to match.
So multiply 1 minus cosine x to the right and sine x to the left.
I think that's right. I mean, at the very least, now they have matching denominators. So why don't you clear out the numerators and see if you can see how far you can take it from there. Are you okay up to there? So sine times sine squared. FOIL the one on the right. I do like that there's a 2 showing up because all my answers have a 2, so that's maybe a clue that I'm sort of on the right track, although this certainly doesn't look anything like that. Any ideas? I see something standing out to me.
Cosine sine squared, cosine squared and sine squared would equal 1.
Yep, sine squared plus cosine squared is 1.
So that's 2.
And then 1 plus 1 is 2.
2 minus 2 cosine x. We cancel.
Oh. Oh, I see something else that's about to happen. Let me slow down. Are you okay with that?
Can you take one of the...
I thought this was going to get ugly, but it's about to get better. 2 minus 2 cosine in the top, 1 minus cosine in the bottom. We did this on an earlier problem. What can I do with 2 minus 2? I could factor out the 2. And it's always helpful if you can do the next step in your head, because if I factor out the 2, what's that going to leave? 1 minus cosine. Is that good news? Yeah. So I guess it's always helpful in math to be able to do like one extra step in your head, but it's really helpful on these proofs because you can figure out if I need to take that step or not. If I factor out a 2, it's like, oh, that's a great idea because then the 1 minus cosines will cancel. Then I'm almost there. 2 over sine. That would be the same thing as
2 over cosecant, or
2 cosecant, because the sine in the bottom would be a cosecant in the top. So that one was more about getting a common denominator. That's a pretty common thing that's going to go on today. If your problem starts with 2 fractions and it ends with 1 fraction or 1 statement, the only way that's going to happen is if you get a common denominator. And so you kind of look up earlier, and number 3 is like that, number 4 is like that, where there's 2 fractions to begin with, and your answer, none of them have 2 fractions, so you know you're going to need a common denominator on 3 and 4. So there's a little hint. I want to do number 6. You're going to have time on your own to work on some of these later. Number 6. Oh, I remember why I picked number 6. Because you haven't seen this in forever. Sine cubed plus cosine cubed, like that's not one of the Pythagorean identities. There's not one of those. And yeah, it's like, well, I can't factor anything out because that's all sines and that's all cosines.
But you put a cube on
And I can't like factor out a cube. That'd be nice, but that doesn't work either. And there's not much I can do in the bottom. Again, here's why I picked this one, because you probably wouldn't have got this. A cubed plus B cubed, do you remember how to factor that? You remember the word that goes with how to factor that? Starts with a S. Soap.
Smile.
Somebody's like, yes, that's what I was thinking. Soap tells us the signs, same, opposite, always positive. For the A and the B. So A and B go in the first blank. And then it's the first one squared and the last one squared on the end, and then just put the two together in the middle. Ooh, it's right. That's old news. In theory, we know it, but man, it's been a long time, and you don't use that very often. Okay, but let's apply that to sine cubed plus cosine cubed. And then hopefully something will cancel. So sine is in the place of A, cosine is in the place of B. So sine of x plus cosine of x. And then sine squared. I'm following my pattern down here, and that's what factoring is, following the pattern. A times B, so good, minus sine x cosine x. And then the last piece is cosine squared. And in the bottom we still got 1 minus sine times cosine. Yeah, that's why I did number 6, because I don't know that anybody would have. I think that's even the one, I'll confess. I think that's the one I looked on the key, because I was like, what do I do with cube? We haven't done anything with cube. And then I saw that Miss Murray had factored it. I was like, oh, indeed, we can factor that. But it's been a while. Okay, we're not there yet. Anything you see up here that's helpful? Be careful. Sine plus cosine, is that equal to 1? No, only if it's squared. So some people see that and they're like, oh, that's 1. Like, no, it's got to be squared. Speaking of,
there's sine on the far right, yeah.
Yeah, there's a sine squared plus cosine squared.
It's on the opposite sides.
They're still being added, right? If you want to take the step to move it in front and write it, you're like, I don't want to do that. I'm just going to see that sine squared plus cosine squared is 1.
So that becomes 1 right.
Oh, that's really good news. Because that's the denominator. And even though these things are complicated, they've all got these little Easter eggs, little surprises buried in them, like that when you're on the right track, it's like, oh, look at that. Imagine that.
Cross out.
Those cancel out. And so this looked impossible, and then 2 steps later, it's A.
Yeah, I would not.
No, I know, and that's why we did number 6, because factoring cubes, you haven't done that in forever. And I get it. That's why we did it together. Big picture, I should have mentioned this first. 1 through 6, those are all simplify problems where you don't know the answer. I mean, at least they're multiple choice, so you kind of know where you're headed. The rest are proofs. Again, is that good news or bad news?
Good news.
I say it's good news because now you know what the answer is. Sure, for number 1. Yeah, I mean number 4. That way you could have a common denominator to shoot for. Let's do some proofs together. Not the ones I have circled. Those are for a different reason. Let's do number 9. We'll do 9 and 11, and then we'll do something we haven't done all year. Curious to see how it goes. Number 9, proofs. Okay, so working on one side at a time. One side only, but at least we know what the answer is. I assume we all agree on which side we should start with on this one?
Yeah.
Because there's nothing I could do with the right-hand side.
Definitely not.
Well, you could
Make those two.
So, what do you think about the left-hand side?
Fix the cosecant first.
What do you mean by fix the cosecant?
Well, it just changes the sign.
The cotangent.
So, I guess the first thing I see is nothing squared. So, all the Pythagorean identities are off the table, at least for now. So, you don't like cosecant? I'm fine with that. What do you want? What would you replace it with?
1 over.
1 over sine. Now, would that help?
1.
Maybe. Maybe not. Not initially, anyway. But I think that's still a good plan. Although that alone doesn't do much for me.
Yeah, change the tangent.
Let's change the tangents. Maybe that'll help. Certainly helps on this one because the signs will go away. Okay, I think this is good. Right, the signs will cancel. And then I have sine squared. What about getting a common denominator? We sort of lucked into one. Okay, so I don't have to worry about that. Sine squared minus 1. Okay, squared, like red lights are going off in my brain.
Sine squared minus 1 is cosine. A squared is
But it's not squared.
So I know that sine squared plus 1, sine squared plus cosine squared is 1.
But it's not cosine.
It doesn't match exactly.
So, but it does equal cosine squared.
So what does sine squared minus 1 equal? I want to rearrange this.
Negative cosine.
Negative cosine squared. Which is good, right? Because remember, you're always, as you're working it, you're always peeking at the answer. Like, you know, it's not cheating. It's like, that's where I'm trying to get to. So does this next step help me get there? Absolutely it does on this one. Negative cosine squared over cosine. And then we're there, because one of the cosines cancels, and we got it. Let's try number 11. Yeah, we're good on time. Even for the activity I want to do after this. I'm pretty sure we can agree on what to do first on number 11, or which side to work on anyway.
Secant squared to tangent plus 1.
You want to change,
Secant.
okay, and if you change secant squared, oh, I see what you mean. You say change secant squared to tan squared plus 1.
Yes.
Other people are going to kind of handle that all at once,
So you can take out the 1.
because then the 1s would cancel. So one way to do it is to say secant squared is tangent squared plus 1, and the 1s cancel.
Why wouldn't you just say that equals cosine squared?
Another thing you could do is say that equals not cosine squared,
Or,
but
sorry.
tangent squared.
Yeah.
Right? Because I'm looking at my list here, and I know that tan squared plus 1 equals secant squared. So yeah, two ways to go. You land at the same place. So either way, this thing ends up as tangent squared. Okay. Which I think is good, because my answer is tangent, so somehow everything else has to cancel out. Thoughts on what we do next?
You change cosecant to
Change cosecant to whatever that is.
and then
Cosecant is 1 over sine.
and you put cosine over 1. And then you can multiply those two together to get tangent. No.
Yeah, careful. If I multiply to get tangent, then I end up with tangent cubed. So that
And cotangent.
cotangent. Is that good?
Yeah.
Cotangent of x. Tangent squared x. You're right. We're right on the edge of it. Maybe it was the other class.
Right back to what we had.
Yes. Yeah, I was gonna say, careful. You could change tangent squared to secant squared minus 1, but I don't think that would be. That's kind of going backwards.
Yeah.
There are times though when you make a switch and you're like, wait a minute, that isn't helpful. I need to go back.
What about the cotangent and the tangent? Because it's just like sine over cosine times sine over cosine, and then the other one's cosine over sine. Can't you just cancel those two out?
Cancel what two out?
The cotangent and one of the tangents?
Yes. Okay. Let me try to. Yeah, you're right.
Okay.
Absolutely right. Let me try to phrase it a different way. What's another way we could write cotangent? It is cosine over sine,
1 over tangent.
but it's also 1 over tangent. That's really helpful in this problem. Like, really helpful, because now one of the tangents cancels and we're left with tangent, which is what we wanted.